The answer is sending all of the KI values would be sufficient. Those are the values that the bank would need to unbind the messages, because the bank can decrypt all the messages using its private key and then divide out the k raised to the EB power from the results. It would be okay to send this, but there's no need. There's no security loss in sending the RI values, except for the one for message X. But the bank's going to learn those anyway, since after it divides out the KI to the EB power, it has all of these values. So at the end of this protocol, Alice will be able to compute message X signed by the bank. So now Alice can spend the bill, give it to Kathy. Kathy can verify the signature, and she could deposit the bill in the bank. The bank checks that this ID has not been spent before and believes that it's a valid bill. If Alice spends the bill again, when Doug gives it to the bank checks the signature but finds that this RI value was previously used. So the bank knows the bill was double spent. The problem is the bank doesn't know who double spent the bill. The bank received the bills from Kathy and Doug, but they weren't the double spenders. They were the ones that were duped into accepting the bill. Alice was the double spender. And because of this blind signature scheme, the bank doesn't know that Alice is the one who spent the bill. So for this approach to work, we need a way to trace the double spent bill back to the person who double spent it. But we also want the bills to be anonymous. So that sounds like a contradictory property. There's actually a way to achieve this.